Hello, everybody. So today is going to be your very first flipped classroom assignment where you will be completing work and power guided notes. So today you're going to just simply watch this video and take your notes on your guided notes as you're watching this. So please go ahead and make sure that is open and that you are ready and prepared to take these notes as I go through the work and power PowerPoint. Now, I am going to go through the entire PowerPoint. Your goal is to fill in any of the words that are missing from your closed notes. So closed notes just means that I've given you the majority of the information, but there's some parts of the information that you're going to need to get from this PowerPoint. At the very end, I'm going to go back and work through the one work equation practice problem. And then I'm also going to work through the 3 power equation practice problems. There's no color change at all in this video, so please make sure that you are paying attention to where and which words you need to add to your guided notes. Okay. So what is work? Work is done when a force causes a change in the motion of an object. But what is motion? So motion of an object must be in the same direction as the force. So that means something is moving, okay? So work is done when there's a force that causes a change in that motion. Work is 0 if there is no motion. So if something is at rest, there is no work, okay? And so you see here that we have an equation where work equals force times distance. An example of work is a weightlifter lifts a barbell over his head. Is work being done? The answer is yes. The motion and the force is in the same direction. So if I lift something over my head, I am doing work because I am doing something with a force and there is a direction, right? There is a distance between what I'm doing. But once the barbell is over his head, he holds it for 3 seconds. Is there work being done? The answer is no. There is no work because there is no motion. So the moment that you are holding something over and you are still, that means there's no work being done. Another example, Dora the Explorer picks up her backpack to put it on. After it is on, she runs out the door to start exploring. Is work being done on the bag? Yes, only when the bag is being lifted up. Okay, so for instance, when I lift up my coffee cup, I am doing work. But the moment that I walk around with the coffee cup, the moment that I am carrying the bag, there is no change in distance. Okay, so if I'm carrying the cup, there's no change in the distance at all. And so there's no work being done. So if I'm keeping it like this, if I'm carrying it, if I'm walking around with it, that is not work. Okay, there's no change. Okay. There are some helpful tips to guide you through these kinds of word problems. Okay, so there's a general guide. It's not necessarily a set rule, but it is really important that you remember this. So if I use the words push, pull, lift, or throw, then work was done if motion occurred. Okay, so pushing something is a motion, pulling something is a motion, lifting something, throwing something, those are all motions that are being done. If you are walking, if you are running, then you are working. However, if you carry something or hold something, no work was done because any motion is in a different direction from the force. And so the exception would be carrying an object up the stairs because that is work because there is a change in the there's a change in the distance. Okay. So again, if you see the words, I'm carrying something, I'm holding on to something, there is no work being done. Okay. So now to the math. Again, work equals force times distance. And so work is measured in joules. A joule is a Newton meter. Okay, so that's what we call it, a Newton meter. So joule equals 1 Newton times meters, or 1 kilogram times meter per second squared times meters. So what is a joule, right? A joule, 1 joule of energy, is the energy needed to lift an apple from your waist to your head, okay? So that is what 1 joule is. And we're going to talk a lot about joules because joule is our main unit for energy. And this is going to come up quite a bit in this unit. So really remember what a joule is, okay? So a joule of energy is the energy needed to lift an apple from your waist to your head, okay? And we're going to talk about how it's connected to calories in the future. I'm going to skip this practice problem and come right back to it. So go ahead and skip that first question. And now let's talk about power. So what is power? So power is the rate at which work is done, okay? So it's about how much work you've done in a certain amount of time. So power equals work divided by time. In this case, our standard scientific unit is the watt. So when we get work divided by time, we get 1 watt. And 1 watt is the amount of power needed to do 1 joule of work in 1 second. Okay. So work versus power. How do we know the difference? So running and walking up a flight of stairs requires the same amount of work. How? Well, you have the same force and the same distance. That's the same work. The difference is that running does it faster. And so what does that tell you about power? Remember, power is the amount of work divided by time. So you have more power when you are running versus when you are walking because it's going to take you more time to do that amount of work. Okay. So those are all of the notes that you need. And so now I'm going to turn on my dock camera and show you how to complete the practice assignment. So for the work practice problem, in your guided notes, I want you to follow what you're going to see in my document camera. So please don't write down anything you see up there yet. There's nothing there. So let me go over the practice assignment and then show you. Of course, my dogs are barking. So imagine a father is playing. Imagine a father is playing with his daughter by lifting her repeatedly in the air. How much work does he do on the child with each lift, assuming he lifts her 2 meters and exerts a force of 190 newtons? Remember, our first step is to make sure that we have the correct equation. So work equals force times distance. Okay. The second thing we need to do is make sure we know what information we have. So what information was given? They gave us the force of 190 newtons, and they gave us the distance of 2 meters. Now I'm just going to go ahead and solve the problem. And so we have that work equals 380 joules. Going to leave that there for a second so you guys can capture that. You can also pause the video if I'm moving a little too fast. Okay, next practice problem. Now we're going to do a power practice problem. While rowing, it's not coming off as cleanly as I need it to. Okay. Now the next power practice problem is saying, while rowing across the lake during a race, John does 3,960 joules of work on the oars in 60 seconds. What is the rower's power output? Okay, so one, we need to make sure that we have the correct equation. So power equals work divided by time. Okay. Question 2, or part 2, is going ahead and fill in the information we know. So power is going to equal the amount of work, which was 960 joules, divided by 60 seconds. Okay, I'm going to go ahead and solve this equation using a calculator, of course, just to make sure that you guys always use a calculator. Please do not rely on your ability to do long division. Most of you guys cannot do it as well as you might think you can. And you're going to get that the power is 66 watts. Again, if you need me to pause here, you can pause at this point to make sure you have this practice problem done. The next practice problem using the same power equation says that it takes 100 kilojoules of work to lift an elevator 18 meters. If this is done in 20 seconds, what is the average power of the elevator during the process? Okay, so we just need to find the power, okay? Because again, the power is telling you that for every second, right, this is how much work is being done. So first, the first thing I'm going to do, and I'm going to call this 1A, is I'm going to convert the 100 kilojoules into joules. Okay, so 100 kilojoules, we know that kilo means 1,000, so 100,000 joules. Okay, because kilo means 1,000. Okay, so we have 100,000 joules. So now it's going down to step 2. The amount of power I have, it took 100,000 joules to go up 18 meters. And it was done in 20 seconds. Okay, now some of you guys are probably wondering, why did we have that additional information about the 18 meters? It's just telling you how high it went up. We don't actually need that information at all to find out the amount of power. Okay, so I'm going to go ahead and solve this equation. Okay, and I'm going to get 5,000. Okay. Again, sorry for all the noises you guys are hearing. That's what happens when you're doing this live. Okay. All right, and our last practice problem for today. If a person pushes a lawnmower with a force of 500 newtons over a distance of 20 meters in 120 seconds, what is the power? Okay. First thing we are going to need to do is find the work. So we have to use the work equation first, okay, because we didn't have the amount of work. So we're going to use this equation. Okay, so it's going to be work equals 500 newtons multiplied by 20 meters. Okay, that should give us, I believe, 10,000 joules. But let me double check because, again, we always want to double check our work. Okay. So now I'm going to use this part to help answer the power question. Okay, so I first had to find out what was my amount of work, and now we're going to use that answer, and I'm going to input it into the power equation. So I just put a box around it to remember that we need this information. So let me just put this down here because I need to erase all that. Okay. All right, so for power, the power equation again is work divided by time. So if power is going to equal 10,000 joules, right? That's what we found from the previous equation. And it's going to be divided by 120 seconds. And you should get 83.33 repeating watts. And this is going to be your final answer. Wait, what's going on here? Why can't you guys see my talk cam? Oh. Okay. All right. So that is going to wrap up your very first flipped classroom assignment. I'm going to review this video to make sure that it is good enough for you guys to look at. Please let me know if you guys have any questions. There might have been an error with this video, so I might need to show you guys how to do that last practice problem again. I have no idea how the dot camera kind of got a little messed up with the connection, but it ended up my not being able to record. So I'm going to review that really quickly for you guys and make sure that you have everything you need to complete your notes. Please send me a private message or comment if you weren't able to capture everything you needed for your notes, or if you were confused about how to fill in the blanks or how to do these practice problems. But we're going to get straight into the practice problems once I see you guys on Tuesday and Wednesday. Don't forget this, there is a 3-day break, so please be safe and continue to socially distance, wash your hands, and use a mask.